Till now we have dealt with single linked list. In the earlier videos I have described that mainly there are three categories of linked list. One is a single linked list, next circular linked list, and then double linked list. Double linked list we will be seeing in the coming videos, and in this video I would like introduce you to the concepts of circular linked list. Okay. By the word itself we can see something there is circular about the pattern in the linked list. In earlier situations of single linked list, we have seen that there is no circular pattern. That means you don't go round. In this section what happens is you go round in the sense you have a linked list here, and probably this is the last node. The last node will be pointing to the header node, right? In single linked list we have seen that naturally mostly the last nodes will have the address part as null, right? But in single linked list you don't have a concept of null value or a null address in any of the link part of the nodes. So naturally the last node will be pointing to the header node, that is it will be pointing to the first node, not first node, the header node itself. So this circular path is mainly giving the name of the linked list as a circular linked list. The main advantage of circular linked list is the accessibility of the nodes in the linked list. In single linked list, if you want to access a particular node, you have to anyway start from the header node, right? So but what happens in single linked list is if you have a particular node or you are standing in the particular node, you can go through anywhere. Any node can be accessed without the help of the header node. That is the main advantage of circular linked list. Next we can see the implementation of search algorithm in circular linked list. We have seen how we can do search algorithm in single linked list. The same is the concept except for the one of the conditions. There we have used a flag variable. Here we need not use a flag variable because we can go on searching until you find or you reach the header node, right? Here also the flag variable, and there another condition that was displaced is ptr equal to null. The loop continues until you have a condition of ptr until the ptr becomes null value. Here we does not have such a condition. Instead what happens is we have to look whether ptr is again becoming equal to header node, right? So we'll start with a header link. Header link naturally ptr equal to header link naturally means that ptr will be pointing to the first variable. Let me put values. Let it be 15, 25, 35 and 45, and I will give the key value as suppose 35. Now header of link equal to ptr means naturally ptr will be pointing to the first node. Now check the while condition. While condition has two conditions. One, the data part should not be equal to the key value, and then also ptr should not be equal to the header value. This while loop works until the conditions are true. So the two conditions, there is the data part of the node currently we are processing should not be the key value, and moreover the node should not be the header value. So if these both conditions are true, what we have to do is you have to go forward in the linked list, that is you have to traverse each and every linked list, that is the single statement ptr equal to ptr of link. So this both conditions exist, exit according to when either of the condition becomes false. So suppose this condition becomes false, that is ptr of data part becomes the key value. We will, in this example which I have given, this happens, the condition, this while loop will be exited when this condition becomes false, that is the ptr of data value will be equal to key when the while loop is running for third time. So what happens, it does not enter into the in the third running time of the loop, the loop statement is not executed. Naturally the if condition will be executed. So what is if condition here? Ptr of data equal to key. Ptr of data, when ptr of data equal to key, what we have to do? We have to return the ptr, that is we have to return the address of the current node. That is naturally I have reached here, ptr will be pointing to the third node and the data part is the key value, and naturally I will be returning, this statement will be returning the address of the ptr value. Now suppose we have another key value, let's say 55. So what happens here? The while loop get exited according to this condition. That is, we have checked for 15, that is not the key value. We have checked for 25, that is not the key value. 35, 45. Naturally, I have reached the last node. Now what happens here? When I reach here, it goes to the header node. It will be pointing to the, now ptr as an incrementing statement will be working. The ptr now will be pointing again to the header node. So I have told you before, if the ptr is again pointing to the header node, that condition will be exited. So ptr should not be equal to header node. I have told it before as a condition. So when this condition becomes false, that means I have not found my key value. Now what happens is the else statement is executed, giving that a message, the search is unsuccessful. Now we will be looking for the merge circular linked list. Next we will look for the merge algorithm in circular linked list. Naturally, merging means you have to join two existing linked list. So we are dealing here with circular linked list. Naturally, we will be dealing with we have to have two circular linked list. Now let's check for this example. This is 5, this is 10, and this is 12. So I will be merging these two linked list. So what happens here, according to this algorithm, suppose this is the first circular linked list and this is the second circular linked list. This first circular linked list is starting from the header node named as header 1, and the second one starting from the header node 2, that is header 2. Now naturally, with my algorithm, which is here, what happens after the execution of this algorithm, you will have a new merged algorithm where the header node will be header 1, and you have a total, there will be 1, 2, 3, 4, 5, 6, 7 nodes. Four, 5, 6, 7, and what will be the content? We will check with the algorithm. How the both circular linked lists are merged, we will look for the algorithm. So let's start. Header 1 of link, that is the first node which is pointed by the header 1 node, will be given the value ptr1. Naturally, the data 5 containing node is known as the ptr1. That is the first node of the first linked list is given as the ptr1, and the second node of the second linked list, first node of the second linked list is given as a value ptr2. Now we will start from header 1 of link. Header 1 means this node is header 1. Now what happens is, according to this assignment statement, header 1 of link is given the value of ptr2. That means we are going to start the merging steps starts from this statement. So now we are giving, naturally the header 1 of link value is given the value as ptr1, right? That was before this node was ptr1, but when this statement is executed, what happens is, now header 1 of the link part of header 1 will be pointing to the first node of the second linked list. I repeat, header 1 or the link part of the first header node will be pointing to the first node of the second linked list. Naturally, this is the joining type. So header 1, the link part of header 1 now will be pointing to the first node of the second linked list, second circular linked list, and what happens is, you will go for a loop to traverse the full set of this second linked list. So what is the condition that can be done here? Until the link part becomes header 2, that means you have to go continue traversing each and every linked list of the second circular linked list. So naturally the condition will be when you reach the header node of the second linked list. Header node of the second linked list means it is header 2. So until you traverse, until the ptr2 of link is not equal to header 2, you go on traversing the second circular linked list, and that is done with the statement, and this continues until this 45, the fourth node is repeated. So what happens here is you get here 15, 25, 35, 45, right? This is our merged circular linked list. So naturally the header node will be named as header 1. Header 1 will be pointing to 15, then 25, then 35, then 45, right? Now what happens here is at this when it reaches 45, naturally 45 is pointing to the header 2. So this while loop get exited, and now next statement will be executed. What is it? ptr2 of link is equal to ptr1. So naturally when this when while loop is getting exited, what happens here? ptr2 will be pointing to this node, right? So now what I'm the next statement is ptr2 of link is given to ptr1. What is ptr1? The first node of the first linked list. So naturally ptr2 of link will be pointing to, that is 45 will be pointing to 5. Then what happens here? Naturally this total linked list will be merged. So naturally 10, 12. And what happens here is 12 will be earlier 12 is already pointing to header 1, and that is not rewritten here. But what happens here, as a result, one node is not being used further, which is that node, header 2 node, right? Header 2 node is not need not be used further, because that duty of header 2 node is taken care of by the header 1 node, and naturally header 2 node is unused here. So we return this header node to the memory bank using the return node algorithm. We have seen in I have told you already in earlier algorithms that if you are not using a particular node, then you have to return that node using the return node algorithm to the memory bank. Naturally header 2 node is returned to the memory bank using the return node algorithm. So what happens here in the merge algorithm? We have two linked list, circular linked list, already existing two circular linked list, one starting with header 1 and one starting with header 2. So after this algorithm is executed, what happens here? Header 1 will be pointing to the first node of the second circular linked list, and at the end of the second circular linked list, it will be pointing to the first node of the first linked list, and the last node of the first linked list is already pointing to header 1 itself. So naturally header 2 node is becoming unused, and it will be returned to the memory bank as we have seen in the algorithm. So this is how circular linked list works. Next we will be seeing the double linked list in the next videos.